Hello, welcome back to chapter 13-2, angles of rotation. And in this video, we're going to connect the angles of rotation with SOHCAHTOA, with the sine, cosine, tangent functions, and also the reciprocals. And we're going to now figure out how to find trig functions of angles that are not acute, whether they're obtuse or it's an angle of rotation that's even beyond 180 or 360, or even negative angles of rotation. So this is what's going to happen. We're going to start with what we know. So we're going to start in quadrant 1. Now, let's say that I have an angle of rotation that looks like that. And don't worry if it looks like 40, 45 degrees. It's random. Don't worry about that. This is my angle of rotation. Now, this is already acute. So the angle of rotation, which is less than 90 degrees, and we're going to talk about positive, so it's going this direction. The angle of rotation is equal to its reference angle. Just like we showed in the previous video, in quadrant 1, for angles that have not rotated all the way around, I need to include that statement. But in quadrant 1, for like just one rotation, then, or under one rotation, I should say, we end up with angles of rotation that are equal to its reference angle, because we know what to do. So I'm going to draw a triangle like this, and I'm going to make that a right angle. Now check this out. If this is angle theta, we'll call that angle theta. Relative to angle theta, this is the side opposite. This is the side adjacent, and this would be the hypotenuse. But there's a very important idea here. If I have my angle of rotation, my terminal side here, and I do draw this side, and I can kind of draw it wherever I want to draw it. Well, you'll see where we get it in a second. I get a point right here. These two lines, this is a line segment, but these two lines intersect at this point. This point, I don't know what it is because I didn't measure anything. We're just talking in general. This point right here has coordinates x, y. Has the x coordinate and the y coordinate. Whatever the x is, whatever the y is. Check this out. This is what this means. To go from the origin to find those coordinates, I go to the right and I go up. I go to the right x units. So the adjacent side represents x. And the opposite side, how far I'm going up, represents y. So if, I'll sketch it here real quick. If my point that I have goes through 5, 3. So 5, 3 is on this terminal side. That means, move it up so you can see it, that means that I went 5 units to the right and I went 3 units up. Okay, that's cool. That gives me, if I know the point, that gives me both the opposite side and the adjacent side. Well, how do I find the hypotenuse? Got to use the Pythagorean theorem. So if this, and we use r for radius, we'll explain why later, just go with it for now. But we say r to the second power equals 5 to the second power plus 3 to the second power. So I end up with r is whatever the square root of 5 squared plus 3 squared is. And in general, over here, the hypotenuse, which again we're going to call r, is going to be the square root of whatever x squared plus y squared is. And again, just the positive, not the negative. I know that when we solve quadratics, we end up with one positive, one negative, but we only want the positive because we're dealing with a distance. So keep this in mind, that r is always going to be positive. Now you might be thinking, what about x and y? Are x and y always going to be positive? No. What happens if I'm in quadrant 2? So again, here's my x coordinate, here's my y coordinate, but in this case, I went to the left, so this x right here, that's going to be negative. The y is still going to be positive, and to find the r, I would take whatever x is and I'd square it. That becomes positive. A negative times negative is a positive. This would still be y squared, still be positive, and I'm still going to use the same thing. And you can talk about it more. I won't do it in the video, but if I'm in quadrant 3, both the x and the y are going to be negative, and if I'm in quadrant 4, the x is going to be positive and the y is going to be negative. So this will show up. So up here, I get positive, positive in first quadrant. In quadrant 2, I get negative, positive. In quadrant 3, I get negative, negative. And in quadrant 4, I get positive, negative. So the x to the right is positive, the x to the left is negative. The y going up is positive, and the y going down is negative. Now, going back to this one, if I have SOHCAHTOA, the opposite is y, the hypotenuse is r, this is opposite, this is the hypotenuse. So going back to quadrant 1, my y coordinate represents the opposite side of the triangle, and the r represents the hypotenuse. Sine is opposite over hypotenuse, so I can just say y over r. So whatever the y coordinate is of that point, over that distance r. Cosine is x over r, which is adjacent over hypotenuse. And tangent is y over x, which is the opposite side over the adjacent side. And I need to add this one little caveat. You can't divide. Remember we said r is always going to be positive? Well, greater than 0, so it can't be equal to 0. But here, yeah, x could equal 0. If x equals 0, that means you've got a point somewhere on the y-axis. And if that's the case, tangent is undefined. We can't do that. We can't divide by 0. So that gives you the background for how this works. This allows us to go from what we normally just nickname SOHCAHTOA when we're dealing with right triangles in geometry, to now we're talking about angles of rotation. And it's not that hard. So I have an angle of rotation. I don't know what the measurement is. I don't actually know what the angle is. That will come later. I know, I do that all the time. But I know that the terminal side goes to the point 4, -5. So that tells me that x equals 4 and y equals -5. Now those are 2 of the 3 things that I need. What I now need is the distance from here to here, which we're going to call r. So I know that r is equal to, and I'll do it this way, the square root of 4 squared plus -5 squared. So 4 squared is 16, -5 times -5 is 25, and this gives me the square root of, I think, 41. Now, you're going to be tempted to grab one of these and do this. Square root 41. Don't. Do not estimate. You can leave it as a simplified radical. Now, what I mean by simplified, for example, if I had gotten like the square root of, like, make up one here real quick, 24, I know that that's 4 times 6, so that would have been the square root of 4 times square root of 6, or 2 times square root of 6. 41, I should check to see if I can simplify it. What's the largest perfect square that is a factor of 41? Well, it turns out 41 41 itself is prime. It doesn't mean that it has to be prime, but 41 just happens to be prime, which means the largest perfect square is going to be 1, and the square root of 1 is 1, and that's trivial, so we're not going to do that. So we're going to leave the square root of 41. Okay, so now let's go back to this. Sine is y over r. So sine of theta, and that's my angle of rotation here, is going to be the y over the r. I'll rewrite what's on the other sheet so when you look at just these papers you can see it. Using the y and the r that I have, my y is 4 and my r is the square root of 41. Now if you're paying attention, you'll know that I can't leave it that way. I have to rationalize it. This is going to end up being 4 times the square root of 41 over 41. The cosine of theta is going to be x. I'll write it up here. Cosine of theta is x over r. And I'll write the tangent one too. I'm just writing these. Tangent of theta is going to be y over x. Okay. And I know x is not 0, so I'm okay. Cosine takes x, which is 4. Oh, rats. Sorry. This was 5 from the previous part. And I just demonstrated a mistake that a lot of people make, and I even made it. I just grabbed the first one. I'm sorry. So it's 5 times the square root of 41 over 41. And like I always do, just because I'm lazy, I'm not going to redo this and edit it. I want you to see that I made the mistake, okay? So that you guys can understand that it's okay to make mistakes. I caught it. Cosine is the 4 over square root of 41, which is going to be 4 times the square root of 41 over 41. And tangent, and actually, to be honest, that was supposed to be a negative 5, because it wasn't 5, it was negative 5. Tangent of theta is going to be y over x, so negative 5 over positive 4. Yeah, so hopefully when you're doing your work, you're not making a video with it, so it's not going to be recorded, your mistakes for posterity. But essentially what I did was I found what the r was, and then I just used y over r, x over r, y over x. At least that's what I should have done. And then found my sine, cosine, and tangent. Now, I keep bringing up this is going to go places. Check this out. I don't know what that angle theta is. But guess what? Let's see if I'm in degree mode. Yep, I'm in degree mode. This is what I'm going to be doing. Let's do tangent. Let's see what happens. Do what we call inverse tangent. Negative 5 divided by 4. And I got negative 51.3 degrees. And if I do inverse sine of negative 5 divided by square root of 41, I get the same thing. And if I do inverse cosine of 4 divided by square root of 41, that one gave me 51 degrees. Something's up about that. We're going to explain that later in a different section. But it looks like this is going to represent negative 51 degrees. We'll see you in the next video.